Our project concerns the seam carving algorithm. The algorithm seeks to implement a better method of resizing images without distorting the important content within the image. Here's the problem. When you resize a picture, you could change the proportions of the image, but then you would end up with a distorted image like our squished cow here. You could crop the sides of the image, however you could easily crop out important content that was on the edges of the image, like the cows off in the distance on the left and right. There is a way to remove unimportant pixels more judiciously than just chopping them out. We could have a seam that runs the length of the image. The seam could look for pixels that don't really matter that much and gravitate towards those pixels. Then we could have a whole bunch of seams and just remove those seams that contain relatively unimportant information. Then, when these seams are removed, we end up with an image that maintains the most important content, but removes the more unimportant pixels. For basic usage, type java-jar, the seam carving jar file's path, the image argument with a path, and the output argument with a path. If you want to specify the number of pixels to remove vertically or horizontally, specify vertnum and horsnum. You can specify the height to width ratio using the height to width argument. You can use the help argument to see the usage of these arguments and more available options. Using the web GUI, you can upload an image by using the Browse button. You can allow for seam insertion instead of seam carving by selecting Yes from the Seam Enlarge dropdown. You can also specify how many pixels to remove vertically or horizontally using the appropriate dialogues. You can also alter by percentage. The user can also upload the image via drag and drop as seen here. In both upload options, you have the chance to view the energy, seams, and final image created. Use the Play Slideshow button to see these images as a slideshow. So how does this all work? The first step is to calculate the energy of each pixel in the image. Let's say we were trying to calculate the energy of this pixel right here. The first thing we would do is calculate the average color of the pixels in the immediate area around the pixel. Then we would find out what the difference of color was between the pixel in question and the average color of the pixels around it. If we visualize this process, it would look something like this. The next thing we would need to do is determine the seams in the image. We have to break down the larger problem of determining the best seam to remove. We consider what is the best path for a seam if it has to go through just one pixel. Well, the seam could come from above, the upper left, or the upper right. The best seam would be the seam with the lowest energy. So we take the lowest energy option available. Then the cost of the seam at this point would be the sum of the energy of the choice we made and the pixel. So on a larger scale, we might have energies for pixels like these. We look in the second row for what is the best case seam above it. We calculate the cost of the best case seam for each pixel in the second row. Then we repeat this process with the row below. When we arrive at the bottom of the image, we find the best seam by searching for the best case seam available. From there, we just need to repeat this process of finding the next best case seam until we arrive at the result for which we are looking. Here's the whole process in action. Instances where the algorithm receives less than desirable results are where the image is very busy. In this image here, there aren't many good seams to remove, so we end up with a bit of a squish cow. The algorithm has the most success in images where the background is fairly consistent in color, like this image here.